Good evening, everyone.
Good evening, ma'am.
In today's session, we are going to discuss PPA of week. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So the week 10, it covers the files concept. All of you switch off your mics now. So let me just briefly give some introduction and then we'll start the PPA. So when you are working with files, so till now, whatever the data that we have used in your programs, so once we terminate the program, the data will be lost. The data that we stored in those variables will be lost because the memory allocated to that variable will be removed once we come out of that program. Whereas if you store the data in a file, that will stores permanently. Today you can store the data and tomorrow also you can able to access it. Once we store in a file, so that data you can able to access it whenever you require that. Okay.
If
So
we write in a write mode or read mode.
creating means write mode. If you want to access it, read the content of a existing file, that is called read mode.
Okay.
Okay. So once we store the data in a file, that means when you write something into it, you can store it. Okay. So it will be stored permanently. That is the advantage of files. Okay. So whereas we have mainly two types of files, text files and binary files. In the text files, the data will be stored in text format, character format. That means ASCII format. The data will be stored in ASCII format. Whereas in a binary file, the data will be stored in ones and zeros. Okay. Say for example, we have written say 12 into your file. Suppose I have written the data 12 into the file. So if it is a text file, it will take the ASCII value of 1 and 2, and that ASCII value, it will, according to that ASCII value, it will store the data. Okay, in the text format. Whereas if it is stored in a binary format, so what is the binary equivalent of 12? So it is 1100. So it will be converted into binary, and that binary value it will store it. Say suppose we consider this as a number, and we are storing using 32-bit or 16-bit or 8 bits like that. Suppose if you are storing using 8 bits, so it will be stored like this. If it is a binary file, it will be stored in ones and zeros. Whereas if it is a text file, for each character, it will take 1 byte. So in 2 bytes, it will store it like this. Okay, in a text format. The ASCII equivalent of 1 and ASCII equivalent of 2, it will take and then store it. Whether it is storing in ASCII format or EBICD format. So for storing the data in a text format, there are so many ways. You can, most popularly used is ASCII format. Okay. So if you store the data in a text file, you cannot able to process it, the numerical value. Suppose if I store the student data, student number, name and his marks. Suppose at the end I want to find the total marks of the student in all the five. Suppose 5 subject marks I have stored. At the end I want to calculate what is the total and average mark of that student. So that type of calculations you cannot able to do it if you store the data in a text file. Suppose if you store the data in a binary file, then later you can able to process the numerical data easily. Okay, so
Yes.
that is another advantage of binary files. And if you store the data in a text file, it is readable to the humans, but it is not readable to your computer. So
Yeah.
you need a translator. So processing the data in a if you store the data in a text file, processing will take more time, because internally it is stored in not understandable form of your computer. First we need to translate it, and then your computer will able to understand it. So processing will take more time. Whereas if you store the data in a binary format, so a processing may take somewhat lesser time. So that is another advantage of binary files. And even for storing the data also, sometimes it will take more memory. Say for example, if I store 2, 3, 4, 5. Suppose if I store this value in a binary format, it will take only 2 bytes, maximum of 2 bytes. Whereas if I store the same value in a text file, it will occupy 4 bytes. See, 2 is one character, 3 is another character. Each character it will take 1 byte. So it may occupy 4 bytes. So memory taken might also be more in case of text files.
And
Less
ma'am,
in
how
case
it
of
takes
binary.
2 byte when we use the binary?
Integer range is 30. Any number which is between 32,767 to 767 will take only 2 bytes.
Okay.
Okay. So like that, there are some advantages and disadvantages of storing the data in a text file and binary files. Okay. So generally, if you store the data in a text file, it is readable. When you open it, you can able to see what is the content of it. But if you store the data in a binary file, it is not readable,
Yeah.
not understandable for.
And we
Okay.
cannot perform any kind of program with it.
Yeah. Yeah, you can do the programming, but it is not human readable. Okay.
Okay.
Whereas it can be machine readable, no problem. Okay. So so that is a differences between text and binary files. So whether you are working with binary or text file, whatever it may be, what type of file it is, so when you are working with the files, you need to follow certain steps. First we need to open that file for a specific purpose, and then perform the operations on it, read or write operations. Okay. Perform operations on it, and then once we perform the operations, required operations, then you have to close it. At the end, you need to close it. Close the file. Okay. So this is the, whenever you are working with any file, whether it is text or binary or any other sort of file, random file, whatever it may be. So first we need to open that file for what operation you want to do on that. Generally, the most general operations that you can perform on a file are reading and writing. Okay. So open for specific purpose, whether on that file, whether you are going to read or whether you are going to write, you need to specify when you open it. And perform the required operation. For what purpose it was open, perform that operation. If it is open for reading, you read the content. If you open for writing, you write the content. Once your task is over, you have to close that file. Okay. So this is the order you need to follow when you are working with the file. So to open the file, to perform all these operations, we use certain built-in functions. All those functions are defined in stdio.h only, standard input output header file only. Okay. So first we need to open the file. To open the file, we need to suppose you are creating an integer variable. So first we need to declare it. Say a is an integer variable. So after that only we will read the a value, we will utilize the a value, and then once we terminate, the a will be closed. Okay. So the same way when you are working with the files also. So first we need to declare a file pointer, a file stream. We say file stream or file pointer, we need to declare it. So once we declare a file pointer, how to declare a file pointer is use FILE, capital letter. Pointer means you need to use a star, some pointer name. It can be FP or F1 or F10, whatever it may be. So this is the name of your file pointer, and the star indicate that this is a pointer. And what is the type of that pointer is? It is pointing to a file. Okay, FP is a file pointer. So declaration will be like this. This should be in capital letter, FILE. Okay. So first we need to declare a file stream or file pointer. This is called a stream or file pointer. So when you open it, you have to say like that. Fopen is the function that we use. And here we need to mention the name of the file. Suppose if you know the name of the file, you give it in double quotes. Say for example, I am creating a file called sample.txt. So if you know the name of the file that you are reading or writing, you give the name in the double quotes. If you don't know the name, suppose you want to read file name from the user using keyboard. So you before this you read your file name into one variable. Say I have a file name is a string. Okay. So I have a one variable called fname, which indicate the file name and which is a string. So before that you read the fname value, and you can pass the fname value here as a parameter. Okay. Suppose if you are using a variable name as your file name, to store your file name, if you are using a variable, then no quotations, just variable name you mention here. Okay. If your file is a static file, that means you know the name of the file, the physical file, then you give that name in double quotes, because you know the name of the file. Name of the file is always a string. So string is specified using double quotes. Okay. So like this, you need to, first parameter of your fopen is the name of the file. The second parameter is also a string. Specify the mode. Mode of the mode indicate the which mode you are going to, for what purpose you are going to open this file. So this possible mode values are, it can be R, W, A in general. R indicate the read, W indicate write, A indicate append. Suppose if you use your mode as R, that means you are opening this particular file in read mode. So when we can able to open the file in read mode is if it exists already in your, so in your current directory, if that file exists, then only we can able to open that file in read mode. So your reading means the file is already created. So that content you want to see. So that is called reading. So that means if you want to open your file in read mode, so you should ensure that this file exists in your folder already created. Suppose if it is not there, what happened? If it is there, it will open. Open that file and it will return your file pointer will be pointing to the beginning of the file. Starting element, starting character of that file will be pointed by your FP if this file exists. If you open the file in read mode. Suppose if that file doesn't exist, then it will return a null. Error.
0.
No, null, N-U-L-L.
Okay.
Okay, it will return a null value to your file pointer. Because it is a pointer, it won't be 0. It will take it as null. Okay, N-U-L-L. We say. Okay, so null value it will return to the file. Okay, so you need to remember that when you need to open the file in read mode, if it already exists, then only you can able to open the file in read mode. Otherwise, you will get an error. You can think it as like a error. It cannot be able to open the file.
And ma'am, if we open with the write mode, then if it is not, then it create and we can edit it.
Yes. So if you open, so the another mode can be W mode. So when you open the file in read mode, you cannot perform the write operation. So you cannot write new things into that file. Okay, only you can see the contents. You can able to read that content, but you cannot perform write operation. So when you open the file in write mode, so when you are opening the file in write mode, so write mode generally we use it for creating a new file. Suppose in that case, this file name should not exist in your folder. Okay, this file name should not exist in your folder. So then it will create this new file. It create a file with the content given by you with the name of the file is this. With this name, it will create a new one. Suppose if file already exists, what happens is it will overwrite the previous contents. Suppose I have already file called sample.txt, which contains the text hello world. Inside that file, I have stored hello world. So now I have opened the file in write mode. Then what happens is it will overwrite the contents of that file. New contents, whatever that I want to store now, the previous contents will be erased and the new content which I gave now will be stored in that file. Okay. So if file doesn't exist, it will create a new one. If file exists, it will overwrite. If you open the file in W mode. Okay. So if you open the file in read mode, if file exists, it will able to read. If file doesn't exist, it will return the null value. Can't read, like error. It will be in case of read mode. Suppose if it is in write mode, if file exists, overwrite. File doesn't exist, it will create a new one. So you have to know that. Okay. Then the third mode is append mode. So A is also a write mode only. Append mode is also a write mode only. The difference is if the file doesn't exist, it will create a new one, same as your write mode. If file already exists, it will add the new contents at the end of the file without erasing the previous contents. It will keep the previous contents as it is. The new contents will be added to the end of the file. So that is the only difference. If it is W, it will overwrite. Previous content will be erased and new contents will be created. Whereas in case of append, previous contents will be as it is. The new contents will be added to the end of that file. Okay. So that is the only difference. Both are write modes only. W and A are write modes only.
In write mode, ma'am, if it contains present, then it overwrite, means it writes double on it, or it erases first.
It will erase the previous content and then write the new one.
Okay. In append mode, it remains retain that previous one, and we can edit a new one.
Yeah, you can add a new one at the end of it.
Okay.
So that is a difference between write and append. Now you have, so if you open the file in read mode, you cannot perform write. If you open the file in write mode, you cannot perform the read. If you open the file in append mode also, you cannot read. Okay. So there are another 3 modes: R plus, W plus, A plus. There are another 3 modes: R plus, W plus, A plus. They will indicate you can perform both read and write operations on those files. If you open the file in R plus mode or W plus mode or A plus mode, in both the 3 modes, you can able to perform both the operations, read operation as well as write operation. But here you can able to read and write, but the thing is, it will act same like a read mode only. Like if the file exists, it will able to read as well as it can add new content. But if file doesn't exist, it will raise an error. Same like it will act like a read only. But the
Okay.
only difference is you can
We
perform
can
both the
write it, write
Yeah.
on it.
Yes. So in case of W plus also, you can able to perform read and write operations on the file. The thing is, it will act like a same like a W. So that means if the file exists, it will overwrite. If file doesn't exist, it will create a new one. Whereas in case of append, A plus, it will act same like append. If file exists, it will add at the end of the file. If file doesn't exist, it will create a new one, same like append. The only difference is you can perform both reading and writing. Once you, after appending, you can able to read the contents also. Okay. So that is the only difference between R plus, W plus and A plus. Same as RWA only. The thing is, you can able to perform both read and write operations. So these are the 6 modes that we use on a text file. If you use any of these 6 modes, it will create by default a text file. The file which was created is a text file. Whereas if you want to create a binary file, the modes that we use is just and B. Say RB, WB, AB. Or you can also write it like this. Either you can write it side by side, or R plus B, W plus B, A plus B. You can also write it like this. Okay, both are same. RB, WB, AB, or R plus B, WB plus B, A plus B.
For
And
binary.
yeah, if you write it like this, RB means read binary, write binary, append binary. So in these 3 cases, they will be like same RWA.
Yeah.
Whereas the next 3 are same as like your R plus, W plus, A plus.
Okay.
Okay. So these are the 6 different modes. If you use these modes, it will create a binary file. B indicate a binary file. That is the difference.
Can
So
you once tell what W plus and A plus do?
W plus is the same as W, except that you can able to perform both read and write.
Okay.
A plus means same as A, except that you can able to read and write both the operations. So all the 3 are same as these 3 only. The only difference is here you can perform both read and write operations, whereas here you can perform only the specified operation.
Yeah, only read, only write, or only create
Append.
new file.
Yes, only append. Whereas in these cases, you can perform read, write, append. Along with that, when you open the file in read R plus, you can even write also. W plus, you can able to read also. A plus means you can also read. Okay.
Yeah. But only the thing is, the in A plus and W plus is it overwrite and it did not overwrite append. W overwrites.
Yeah.
Okay.
So these 6 are same as this, but this will create a binary file. That is a difference. These 6 modes will create a text file automatically, whereas these 6 modes will create a binary file. Okay. So that is how to open the file. So how to open the file? Next, once we open, we can perform the operations. So what are the different operations that we can perform on a file? We can perform only read and write operations. Okay? Only two operations you can perform on a file. Either you can read the contents of the file or you can store new contents to the file. So reading the contents of the file is called read. Storing the new contents to a file is called write. Okay. So to perform these operations, we have so many built-in functions. Suppose you want to write one character to a file. We use the functions fgetC. To read a character, we use fgetC, getC. These are the functions we use to read a character. Whereas to write a character, to read we use these functions. To write a character, we use fputC, putC, etc. There are so many other functions also, but these functions are important. And if you want to write a formatted data, like suppose I want to write a student product. Okay, I have one product. I have a product ID, product name, and rate or cost of that product. So that format, product ID is an integer, product name is a string, product cost is a float value. So I want to write one complete product information to my file. So which is in the format of %d, %s, %f. So one formatted data, if I want to write it to a file, we use fprintf. I want to write something to a file, we use fprintf. Printf is for writing the something to your standard output device, that is monitor. Whereas fprintf is used to write to a file. Instead of writing to your standard output, we write it to a file. fprintf is used for writing formatted data.
Formatted data means
Like the data which we are having, a specific format. Say, suppose in this file, I am storing all the students' data. Suppose if I said I am storing the student data. So that
okay.
student data is having the format of roll number. So in this format, I am writing the data which is in this format: roll number and name of the student and CGPA of the student. Suppose I said CGPA of the student. So in this formatted data, so every record, every data that I'm going
Okay.
to write it to that file is having the roll number, name, and CGPA. Second student roll number, name, and CGPA. So it is
In
having
same format, it prints the data.
yes.
Okay.
So on a specific format you are writing. So while reading the specific formatted data from the file, we use scanf. For reading from the keyboard, we are using scanf. So whereas for reading from the file, a specific formatted data, we use so to read a formatted data, we use fscanf.
Okay.
We will see the examples for all this. Okay. So like if you want to write or read one character by character, we can use these functions. Suppose you want to write one student information or one employee information or one product information which is having a specific format, for that we use fscanf and fprintf. Suppose you want to read one string Okay, you can use fgets. If you want fputs, write one string to a file, you can use fputs, fgets and fputs. Like suppose if you want to like there are hundreds and thousands of functions, but these are important. Okay, just you need to know the minimum basic functions to write and read the data to a file. Okay.
Ma'am, strings means %, %s, like that.
Yeah, percentage. String is nothing but percentage.
Okay.
So one string, if you want to write it to a file, or one string you want to read it from the file, you can use these functions, fgets and fputs.
Okay.
Okay, so like that, you can use some built-in functions to perform your operations, read and write operations. Okay, whereas like after performing your operations, you have to close your file. Third step is you have to close your file. For closing the file, we use fclose function. Fclose. We use a fclose function. To this, you need to pass the file pointer that you have used when you open the file. So when you open the file, fopen function is returning a file pointer. So this file pointer you need to use as a parameter to close your file. Okay. So a file which is pointed by this file pointer, you close it. That is the meaning. Okay. So this is the function we use to close the file. So now we'll see. So you know how to open the file completely. Now you know how to close the file completely. Now we will see how to perform the read and write operation. There are n number of ways to perform the read and write. We will see one example for each with the given examples. Okay. So these are the minimum basics that you need to know to work with the files. First, we need to open it and then perform the required operation, and then we need to close it. Okay, so with this concept, we will try to solve the programs that was given to us. Okay, now see the first program. Write a function. The name of the function is create file that accepts an integer array and the length of the array as parameters. So to this function, you need to pass the array, integer array, and how many elements are there in that array. That length also you need to pass as a parameters. The function creates a new text file named output.txt. The file that we need to create is, the name of the file is output.txt, and write all the elements of the array from the start and each on a new line into the file. So all the array contents you need to write it to the file. Okay. While writing, each number must be written in one new line in the file, inside the file. Okay. So at the end, close the file. Okay. So that is what you need to do. So you are given how many elements are there. What are those elements? Now your task is you create one file called output.txt. So in this, you need to write this data, each number in one line. So if first line must be this, second line must be this, third line, fourth line, fifth line. That is what you need to do it. So your task is like that. So here, if you observe, so what we need to do, we need to write a function. So it is not returning anything. So name of the function is create file. Already the syntax is given to you. Sorry. So I think not, it is not given. Just you need to create it. Okay. So name of the function is create file, and then what are the parameters that were given to that? So you are given one array of integers and the size. So the size, let it be n. You can call it with any variable name. So I'm calling it as n. So this is the name of the function, create file, which is already given. And what are the parameters that you are passing to that file? Your array and the length, size. So array, I am calling it as ARR. and the number of elements or the size of the array is n. Let it be n. So inside that, what you need to do, you need to create one file, output.txt. So if you want to create a file, so what we need to do, first we need to declare a file pointer. Okay, so this you create the file pointer globally, file star fp. Okay, now you need to open that file, fp equal to f open. So to the open function, first parameter that you need to pass is the name of the file. Name of the file already given to you. What is the name of the file? Output.txt. This is the file that you need to create. And when you want to create a file, in which mode we need to open that file? Write mode. You are going to create it now. So if you want to create, that means you are going to write some new content to it. So you need to open the file in write mode. Okay, so open the file in write mode. So first task is over. You have opened the file. Now our aim is you read all these contents. These are there in already in the ARR in this. And what is the length of ARR? N. So now all these elements we need to write it to your output.txt file. How many elements are there?
5 elements.
N elements. N is
Okay.
given to you. N elements are there.
Yes.
Okay. So n times you write a loop. N times you write a loop. In each time, what we need to do? ARR of I value. ARR of I value. We need to write it to the file. ARR of I value. We need to write it to the file. So to write something to a file, we have so many functions, I said. Okay. So I have opened that file, and if file not equal to null, why I have checked this? Why I have checked this? Suppose if it is able to open the file in write mode, then it won't be null. Okay, so it won't be null. Suppose if it is unable to create a file in the write mode, when it will be unable to create a file in write mode is if there is no memory in your system. So if you are opening the file for the write mode means first we need to allocate the required memory to that file. So if the sufficient memory is not there in your system, then only you will get the null in case of write. Otherwise you won't get null. Okay, so if this is error checking whether my file is opened or not. If it is successfully opened, you won't get the null value. You will get one address. Okay, so if you are unable to open this file, in that case you will get the null. So if you are able to open for write, then only you need to perform the operation. Otherwise not. Okay, so if you are able to open it, then what we are doing? N times we are repeating a loop. What we are writing into this file? So one integer. I am writing the one integer value into the file. So I know that I am writing an integer. So integer means in which format it will be? %d. Okay, %d is the format. And ARR of I value I am writing. When I equal to 0, it will write the first value. When I equal to 1, it will write the second value. And you are said that for each value you need to write it in a new line. So along with the value, I am writing the new line also to the file. That means the next value will automatically goes to the next line.
So it will form the column format.
Yeah, slash and indicate a new line. Okay. Yes. So each number it will write, and then your cursor will go to the next line. After writing, it will go to the next line. Okay, so fprintf is the function, okay, to write a formatted data. What is the format of the data? One integer followed by a new line.
Yes.
So this is the format that we need to write. And so fprintf will take 3 parameters. So first one is the file pointer to which device. Generally, fprintf will take 3 parameters. First one is the device, to which device you need to print this. Okay. If you say here 1, 0 means input stream, 1 means outputs or std, sorry, that is, yeah, here you can say std out, std out. If you say std out, it will write it to your monitor, standard output device. Okay. If you write a file, file pointer, if you want to write to your file, you need to pass the file pointer there. First parameter as the file pointer. So to this file pointed by this file pointer, to that file it will write. Okay. So first parameter is to which device you want to write that file stream you need to pass. For your monitor, the standard file stream is std out. For your file pointer, this is your file pointer in which with which name you have opened this, that is your file pointer. So you are writing to this particular file, this particular file pointed by this file pointer, and this is the format that you need to write the data, and this is the data that you want to write. Okay, 3 parameters. First is the device name, second is the format, third is the value, which value you are going to write, actual value.
And ma'am, we did not need to mention that header file.
All these are in this header file only, stdavo.h. fprintf,
Okay.
printf, everything will be in stdavo.h only.
Because the file things here.
Even file things also are defined. So you can read it from a standard device, or file is also a standard one. Okay.
Okay.
So like from which device you want to read. Suppose you want to read from a standard input device, that is keyboard. std in means keyboard. Okay.
Okay.
If you specify your file pointer, it will read from the file.
And ma'am, yesterday the TA uses that std library dot h lib.
std lib, for certain functions we use std lib, not for fscanf. Okay,
Okay.
fscanf and fprintf are in stdavo.h only, whereas later we will use some fgets or some other functions. So for those functions, they are not standard, they were created ones. So when you are using those functions, we use standard library, stdlib, standard library. Suppose default regularly used, mostly used functions, they will be defined in stdio.h only. The extra functionality that was defined will be in stdlib. stdlib. Even if you didn't include that, when you compile your program, it will specify this function is not defined any header in any of the header file. In that case, you include stdlib. Otherwise,
Okay.
no need.
And ma'am, ARR denotes the array here.
Yeah, this is the
Okay.
array, the parameter that you have passed. So ith element of your array, so I value is varying from 0 to n. So so first it will write 0th element, then I value will be 1, first element, second element, like that all the n elements will be written to this file. Okay. So our file, our task is over. By the time this for loop is closes, you have written all the array elements to a file. Now our task is over. So at the end, you need to close the file. Close that file. Okay. So for closing the file, we use fclose function. This is your file pointer. See here. This is your file pointer. So close your file. Okay. So we have first open for write purpose, and then we have performed the write operation using fprintf function. Here we use either fgetc or fputc, fprint or fscanf. Okay, like the required function, based on what type of data you are writing, you use the required function to write. So here we have used fprintf function. So what is the syntax for fprintf function? It will take 3 parameters. The first parameter is the device to which you need to write the file data. So in case of file, you need to specify the file pointer. Okay. Suppose you want to write that the same message to your screen. So using fprintf, if you want to write something to your screen, you can simply use printf. But using fprintf, you want to write something to your screen. So in that case, the first parameter must be std out. Okay. And then the format, the third parameter is the data, which data you want to write it to the file. This is the syntax of fprintf. Okay. So once you write the data, you close your file. So that is the only, you are asked to write only that create file function only. So whereas main was provided to you in the hidden format. Okay. So we have written the whatever that was asked. So just simply test run the program. So all the test cases were passed. Okay, you can see. So any doubt in this? Just we have created a simple file with the array contents. So the next program is write a function named contains string. So this is the function that you need to write, name of the function that you need to write, that takes a string value as input from the user. So it is reading some string from the user and checks whether a file named notes.txt contains the string value or not. So you are reading one string from the keyboard or from the user, and we are opening this file notes.txt, and it contains some data. Whether notes.txt contains the string which was read by you or not, that is like you are searching whether your string, the string given by you, is there in this file or not. Okay. So the function should return 1 if the input string exists in the file, 0 otherwise. Okay. If the string given by you is there in the file, it should return 1. Otherwise, you need to return 0. Okay. So the length of the input string will not exceed 15 characters. Okay. So you are given a string. So this is the string, say hi. And you are already given notes.txt. You have to assume that you have already exist with a file with the notes.txt. So if hi is there in that, it will return 1. Otherwise, it will return 0. So that is what actually output is not found or not found. So it is 1 or 0. Here output is given as wrong. So found means it should return 1. 1 is the output. Otherwise, 0 is the output. Okay. Here output is given wrong. Found means output should be 1. Okay. Maybe like if you know what is the you need not print the output, no. So output is already printed in the main. Your task is from the function you should return 1 if string is found. Otherwise you need to return 0 from the function. So from the function you are returning an integer value, whereas inside the main, if they receive 1, might be they are printing found. If they receive 0, they might be printing not found, like that. Okay. So this output is not related to you. You should write only the function. That function should return 1 if string is there, 0 if the string is not there. Okay. So this is the name of your string. So this is the name of the string, contains string. It is already given. Okay. So inside that, what we are doing, we are reading a string. Okay. It takes a string value as input from the user. So it is reading a one string value. So that for that we have declared one string yes, and you are reading that string into a variable called yes. Okay. So, and now you open this file notes.txt. So whether to compare whether this string is there in that or not. So first you need to read the contents of the notes.txt, or with the readed value you need to compare your string. You need to compare your string with the readed value from the notes.txt file. So open the file notes.txt file in read mode. I am opening the file in read mode. Okay. So it will return a file pointer. So in the declaration and opening, both will be done in the same line. You can do it. So if file equal to null, that means file doesn't exist. Return the error -1. Okay. So if file exists, it will come to this case. So here for reading the contents of the file, we are using fgets. Fgets. I said to read a string from the file, we use fgets function. So first from the file, we are reading one string and we are comparing that with the string that we are searching. Okay. So fgets function will take 3 parameters. The first parameter is the after. So your from this file, last one is it is having a syntax like this. Fgets has the syntax. 3 parameters. Third parameter first. Let me. Third parameter is your file pointer. So that means from this file pointed by this file pointer, from this file pointed by this file pointer, you read some size, say 100 means it will read 100 characters from this file. So your length of the string, how much string you want to read. In general, a particular line, in each line you will have a maximum length of maximum number of characters in a line will be 80. So you are reading the entire line, one line of text, and that readed value you are going to store it in a string, say str. So there are 3 parameters that are required. What are those? The meaning of this is from this file pointer position, you read 80 bytes of data, that means 80 characters, and that you store it into this string variable. This is the string variable. Okay, so it will read from this file, it will read 80 bytes, and that readed value, it will store it in this. So 3 parameters for fgets. So what we are doing here, your file pointer is nothing but a file. From this file pointer, read these many. How many? And means buffer size. Already we have indicated the buffer size as 100.
100.
So that means it will read 100 characters. And
from
then
one line. From each
this
line.
file, from this file, it will read 100 bytes, 100 characters. You can say 100 characters it will read and store it in this string variable. Buffer is a string variable. Okay.
Okay.
So, so that means think of buffer is it has read one complete line from the file. First line, say for example, first line it has read it. So if you reach, so once we read some content from the file, it will your file when you open your file pointer will be at the beginning. Suppose if you read 10 bytes, it will move 10 position to the right. It will be at the 11th byte. So now we have read the entire line. So your file pointer will be pointing to the second line. Okay. Now if you read, it will read the second line, and your file pointer will move to the third line. Like that, how many bytes we have read or how many bytes we have written, your file pointer will automatically move those many number of bytes. Okay. So now here we have read 100 bytes, so that it will be pointing to your file pointer is now pointing to the 101th byte. Okay. So now buffer is a one string with the spaces. You can say it is not a single string. It is a string, multiple strings, some sentence. You can say buffer is a sentence which contains so many strings.
Words. Yeah.
Yeah, so many words. Now, in that, we need to find whether the given word is present or not. The word which we are given here is a yes. Okay, the readed word is a yes. Whether this is present in this buffer or not, we need to check out. For that, we use a string function called str. Str will take two parameters. First one is the original string, and the second part is the string that you need to search. So the second string, whether it is a substring of this string or not, it will check. If it is a substring of this string, it will return the position of the substring. Otherwise, it will return a null value. If the string is not present in the buffer, then it will return the null. If the string is present in the buffer, it will return the position of that string, substring. Okay. So if it is not null means you found the position. It will return the address of the substring. So in that case, you are making your flag as 1. Initially, you are taking a flag value as 0. That means string is not there. You are assuming that string is not there. So once we found the string, we are changing the flag value to 1. So if you check the flag value, if it is 0, not found. If it is 1, found. So if it is 1, you return 1. If it is 0, you return 0. So based on flag, we will decide whether string is present or not in that file. So once we found if a string is there in this original string, once we found, we need not further search the remaining words. Okay, remaining like in the remaining lines, you suppose in the first line itself you found your string, your required data. Then you need not search for the second line, third line, fourth line, like that. So simply we are using a break. Break will come out of this while loop, and then you close your file, and if your flag value is 1, you return 1, otherwise you return 0 based on the flag value. Okay, so what we are doing, we are reading a one word or a string, and we are checking this file is open for reading, and from this we are reading line by line. So once, what happened when it reaches to the end of the file, if you read the first line, your file pointer will be second line. If you read the second line, it will go to the third line. So like that, it will reach to the end of the file. Okay.
Yes.
So in that case, it will return the null. If you use a fgets function, to read the data, then in that case, it will read a null. Once it reaches to the end, if you are trying to read it again, you will get the null value. Okay.
Okay.
So
Ma'am, what thing we mention here to read the data from the next line?
yeah, next line, not the next line exactly. First 100 bytes you are reading now. Next 100
Yes.
bytes, next 100 bytes, like that. You are reading 100 bytes at a time.
Okay.
So
In
once
first
you
line, it
reach
will
to
read
the
100 bytes. Then it will go to the next line.
next 101th byte, it is pointing. If you
Okay.
read it again, it will read again next 100 lines, 100 bytes. So it will go to the 201th byte. Next
Okay.
301th byte, like that. So that I am calling it as a line. So first line you have read, it will go to the second line. So once, if you again read, it will go to the third line. Like that, it will at some point it will reach to the end of the file. So after reaching to the end of the file, still if you read, it will return null.
Okay.
Okay. So that's why we are checking here. If it is not equal to null, then you compare whether your string is present in this readed value or not, readed string or not. Okay. So otherwise, if it is null, you need not. So your end of the file, you can simply come out of the file. Okay. So if your string is not there in this file, definitely your flag value will be 0 only. If your string is present, then only we are changing the flag value to 1 and then coming out. So you need not further search, because of that you are coming out. And here, if your flag is 1, that means your string is found. So return 1. Otherwise, string is not formed, so return 0.
Okay.
So that is what you are asking. Okay. So in this, which functions we have used to read the data, one string, a number of bytes from a file, you can use fgets function. Fgets function is used to read a string. String contains spaces also. Sentence, you can say, to read one particular sentence. Like from this file, this much size of data you can read and then store it into this variable.
Okay.
String
And
variable.
ma'am, as we mentioned, the 100 characters, it will read from the one line. So it will read the spaces also between the
Yeah,
words.
in 100 even spaces, 100 bytes, whatever it is there, whether it is a space or a number or a text or some explanatory marks, everything it will read, whatever that is there in the first 100 lines, 100
Okay.
bytes. Okay. So that is the second program. So you are writing one function contains string. So you are reading one string from the user. Okay. So whether that string is present in this file or not. So to check that, first we need to open that file in read mode, read the contents of your file, check your content, the readed content with the required string. If it is present in that readed content, you return 1. Otherwise, you return 0. So that is what you need to do. Okay.
Okay.
So the next program. Actually, this is not related to the file. Formatting is given. So we'll come to the third program at the end. So let me go to the fourth one. Okay, I will discuss the third also, but little bit later.
Yeah. Okay.
Okay. So now see the fourth program. Create a program that reads the text from a specified input file and it toggles the case of all the alphabetic characters, convert upper to lower and vice versa. The program that saves this modified text into the new output file. So you are given some text. So you need to convert this text into, wherever there is a capital letter, you convert that into smaller case letter. And wherever there is a smaller case letter, you convert that into uppercase. And that contents, you store it into another file. So
Okay.
that is your task. Okay.
We had to give its vice versa.
Yes, yes. So
Okay.
this is your input. Say for example, this is a test file. So T is in capital letter. So in your output file, T must be in small letter.
Yeah.
HIS is in small letter. So this
It will be
HIS
in a
must be
capital letter.
same content. Whatever you have the content here, the same content you write it to the another file by toggling the case. Upper
Yes.
letters must be smaller letter must be uppercase letter. So that is your task. And you are reading from a file called input.txt. You are writing the converted output to a file called output.txt. So
Yes.
what indirectly what you are doing is you are reading from this file and you are writing to this file. So you require two file pointers. One, this file is to be opened in read mode and this file is to be opened in write mode. So read from this file, convert, and that converted data you write to this file. You are reading from this file, convert, and converted data you write it to this file. So that is
Yes.
what the task you need to do. So okay, let us check that. So like main is given to you. So your toggle case syntax is also given to you. So it is taking two file pointers. One is a like in file, name of this is not a file pointer. So this is a string actually. So input file name, output file name. So this is one string and the character, like character pointer means a string. So character pointer is a string. So this is your input file and this is your output file. So that means your input file is input.txt, output file is output.txt.
Output.txt.
So
Yes.
actually, these are the not fixed names. They have given to you one variable. In file is the variable which contains the input file name. Out file is the variable which contains the output file name.
Output file name. Yes.
Yeah. So input file you open in the read mode. So I said no. If you know the file, you put it in double quotes. If you know the file name in a variable, simply use the variable name. See here,
Okay.
the difference between the previous example and this example. In the previous example, we know the file name notes.txt. So that's why we have written double quotes notes.txt. But here we don't know the file name, but the file name is stored in this variable. So that's why file name, comma, you open the in file in the read mode and out file in the write mode. So two file pointers, IFP input file pointer, OFP is the output file pointer.
Yes.
Okay. Now what we want is, we want to read one by one character from this file. We
Yes.
want to read one by one character, convert that converted character, we need to write it to the second file. So to read a character by character, we have the function called fgetc. To write a character to file, we have a fputc. So fgetc will have the syntax.
F gets read the string.
Fgets, not fgets, fgetc.
F gets C.
Yeah, read a character from the file. It will read
Okay.
one character from the file. Okay. So
Okay.
from this file pointer position, suppose IFP, input file pointer position, you read one character. That character you store it into a variable called ch. Ch is a character variable. Okay. So from this file pointer position, you read one character. That character you store it in ch. So that is
Okay.
the syntax of fgetc. So fgetc will return a character, readed character. So from where it will read? From this input file pointer position. So that is fgetc. Fputc means, so you have your character that you need to write it to a file. So suppose ch is the character that you want to write it to the file. So where you need to write that to? You need to write it to output file pointer. So
Yes.
fputc will have a two parameters. First is the character that you want to write and to which file you want to write. You need to specify two parameters. Okay.
In
Ch
F put
is
C.
the character that you want to write and to which position you need to write. Wherever your output file pointer is pointing, to that position you need to write.
Yes.
Okay. So this is the syntax of fputc and this is the syntax of fgetc. Fgetc means from this file pointer, you are reading a one character. That readed character, you return it. You store it in ch. Okay. So these
Okay.
are the syntaxes of fgetc and fputc. Fgetc will read a character from the file. Fputc will store a character to a file. So the same thing we have used here. So C equal to fgetc of IFP. From input file pointer, you are reading a character. Okay. Reading a character and that character you are storing in a variable called C.
Yeah.
So previously I said it will read 100 characters. When it reaches to the end of the file, it will return the null value. So when you are reading a character, once you return, when you reach to the end of the file, it will return EOF character,
End
capital
of the
EOF,
file. Yes.
end of file, end of file. That is nothing but Control Z. End of file character is Control Z. So it will return Control Z value when it reaches to the end of the file. Okay. So
Okay.
when if it is not equal to EOF, that in end of the file, that means you have read one character. That character is not end of the file. That means you have some character. Okay. So that it
Yes.
will store it in C. And now we need to convert that into upper or lower case. Okay. So we are checking whether it is a smaller case letter. If it is a smaller case letter, it will be between A and Z, small a and small z. If C greater than or equal to small a and less than or equal to small z, generally all your alphabets will be in the having a same ASCII value, continuous ASCII value. Okay.
Yes.
Say
Yes,
capital A means I think it is 65. Okay. Small a, the ASCII value is 97.
97. Yes.
Yeah. So the difference between, if you check the so capital B will be 66. That
66.
continuously they will be stored. Okay. Whereas small b will be
98.
98. So always when you observe the difference between the capital letter and the small letter, it will be 32. Say 97 minus 65. How much it is? 32.
32.
Same way, 98 minus 66.
So the same
32.
difference between the uppercase and lowercase of the
Yeah.
same character.
Yeah, between uppercase letter, the corresponding upper and lowercase letters, the difference will be 32. ASCII value difference will be 32.
32. Yes.
Okay. Suppose if it is a smaller case letter, that means its ASCII value is greater than or equal to small a and less than or equal to small z. That means it is a smaller case letter. If it is a smaller case letter, to get the uppercase value, corresponding
We had to
uppercase,
subtract 32 from it.
subtract, yes, you need to subtract 32 from that. So C equal to minus equal to ante C equal to C minus 32.
Yes.
So you are subtracting 32 from that, so that you will get the capital letter. Your C will be now in capital letter.
Yes.
Else, suppose if your given character is in capital letter, if it is between capital A to small capital A to small z, then to get the corresponding lowercase letter, we need to add 32 to that. So
In
C,
its ASCII
C will
value
be
of that character.
yes. So that you will get the ASCII value of capital letter, a
Yes.
smaller case letter. So what we are doing, we have read one character from this file and then converted that to the required format, either to the capital or smaller case letter. Now that value is there in C. Now that C value you are writing to the output file pointer. So that means this C is now stored in output file. We have read the C value from the input file. We have converted that toggle the case of that, and the toggle value we have written to the output file. Okay.
Yes.
So this will be repeated. This will be repeated till you reach to the EOF character. But that means from the
End
input
of the
file,
file.
you are reading one by one character till you get the end of the file.
Yes.
Okay. And that converting and then storing into output file. So once this loop is over, so that means you have written all the characters from input file to the output file. Then you close both the file pointers. Close the input file pointer, close the output file pointer. Okay. So open first input file in read mode, output file in write mode. So read one by one character from the input file, convert that to the corresponding case, and then that converted value, you write it to the output file. So this is to be repeated till the end of the file is reached.
And
And
ma'am, we can get the output using the append.
no append.
Okay.
You need to read from this file, and output you are asked to store it in another file. That is the program. Save the modified text into a new output file.
Okay.
If you want to write that to the same file, then it will be something different. Okay. You need to
Okay.
use random access files.
Yes.
So that is the program. So that is the fourth program. Then come to the third one now. So the third one is develop a C program that generates a V pattern. V pattern consisting of the backslashes and the forward slashes and the letter V based on the given size. The program should write the pattern, this pattern to a file. So input is from the user to enter integer representing the size of V pattern. So that you need to generate a V pattern like this. So this V pattern you are generating using forward and backward. This is a backward slash. This is a forward slash. And this is the last one is the character V. So
V.
we are generating the V pattern using backslashes, forward slashes, and letter V. Okay, and that you are after generating, you are writing that to a file. You are writing to that pattern to a file. Okay, so your input will be what should be the size of that V pattern. Suppose if you give 3, 2 forward and backward slashes should be there, and the last one must be V character. Suppose
Yes.
if it is 4, then 3 forward and back slashes and then 1 V, like that size. So the input here we are giving is the size. So now if you observe this pattern, first of all, how it will be is, suppose if your input is 3, okay, so if you have a V last from the beginning, I'm
Ma'am,
taking
V is
suppose
nothing but the two slashes, like forward and backward.
like we are using a character V only. There we are
Okay.
using a character V only. So
Okay.
that means there is no space like backward, and you said it is V is nothing but backward and forward only. So that means there is no space between backward and forward slash. So you are looking like a V. Okay.
Yes.
Whereas the previous line, in the previous line, what we will get is a backward slash, after that space and a forward slash. Okay, one space and a forward slash.
Yes.
Okay, so and previous one is one backward slash, two
And one for
spaces, two spaces, and one forward slash. So like not two spaces, I think 3 spaces.
three spaces.
Like wait. Yes, 3 spaces. Okay, and then
Yes.
V. So this is how you are getting, like the 3 means, so in between, like first you need a backward slash, after that you need to leave 3 spaces and then forward slash. In the second case, we are using a backward slash, 1 space and then forward slash. Suppose if I extend this to 4 lines, suppose size is 4, so then what I need to do? Backward slash. Okay, wait.
We had to mention the 4 spaces between the it.
5 spaces.
Yes.
If you
Okay.
observe, you'll get it. Okay, exact pattern you will get it. Okay, so
Okay.
this is, so like if you extend, you'll like if you observe now this pattern, so what you can get is,
Even numbers.
yeah, not even numbers, like there are some in each line. You consider this as the first line, this as the second line, third line, fourth line, like that. Okay, nth line. So your
Yes.
n is the size. N is your size. Okay, so n equal to 4 in this case, in this particular case. So in the nth line, you can say in the nth line there are no spaces in between the, like in the nth line we need to
Backslash and
print
forward
V.
slash.
Yeah,
Yes.
no. In the nth line we need to print V. Okay,
Yes.
in the nth line, whatever it may be, the size of the pattern. So in the nth line, you need to print V. And from 1 to n minus 1th lines, how the pattern will be, and you check it. And if you observe, so this is your column 1. So this is your column 1. In the first line, it is starting from column 1. It is starting from column 1. Whereas second line, is it starting from column 1?
No, it is from
No.
column 2.
Yeah, it is from column 2. So in the third line, it is starting from column 3.
Yes.
So like what happened is, in each line there are some initial spaces that you need to leave. There are some initial spaces that you need to leave. After that, backward slash, followed by you need to leave some spaces. These hyphens are nothing but spaces only. Okay. So in between the backward slash and forward slash, you need to leave some spaces, and then you need to write the forward slash. Okay. So
Yes.
how we will write this is based on, always we think that there is one current line number. So this is my first, let L be the current line number. Let L be the current line number. So L value will vary from 1 to n minus 1 only, where n is the total number of lines.
Yeah, total number
Okay,
of line is given to us is
given
4.
to us. Okay, given to us as a 4. So I want to take the current line because I know that nth line I need to print V. Nothing is to be printed. Okay. Whereas for the first n minus 1 lines, we need to check the similarity. Initially, how many spaces we need to leave. After printing backslash, how many spaces we need to leave before printing the right slash. Okay, forward slash. So that for that we need to derive one formula in terms of the total number of lines and the current line. Okay, based on the similarity, you need to derive one formula uh, on total number of lines and the current line number.
Yes.
Okay, so how many spaces I need to leave in each line initially? First we'll see. Suppose if it is a first line, so if L value equal to 1, how many spaces I need to leave? No spaces.
Yes.
Okay, if it is L equal to 2, 1 space. If L equal to 3,
Yeah.
2 space. That means L minus 1 spaces we need to leave. Like in each line, how, like if my line number is L, if you think that my current line number is L, initially how many spaces I need to leave? L minus 1.
Yes,
Where
1.
L value I am starting from 1, if you think. Suppose if I think that my L value is starting from 0, so I need to leave L spaces, isn't it?
Yes.
If my L value is 0, my current line number is 0, always we take the loops or indexes always from 0. Suppose if I am starting, my L value is 0, that means 0th line, I need not leave any spaces. For first line, I need to leave one, like L spaces. Initially, I need to leave L spaces.
Ma'am,
Okay?
for initialization.
No. Initial space.
To give a space between two
See, first
forward
line,
slash and
there
backward slash.
we are always starting from column 1, first line. Whereas second line, where we are starting, we are giving, like here there is one space. After that, we have used the slash. In each
Yes.
line, what are the initial spaces that you need to leave? That I am discussing. L spaces I need to leave, where L is the current line number. So what is the L value? L value will vary from 0 to n minus 2. If you start from 0, it will be n minus 2. If you start from 1, it will be n minus 1. So if you start from 1, you need to leave L minus 1 spaces. If you start from 0, you need to leave L spaces. It's your wish. Okay, you can write it in any way, code. After that, what we need to do? We need to print backward slash. And
Yes.
then how many spaces that we need to leave here in between backward and forward is
N plus 1.
2 into n minus 1. Let me check it.
Okay.
Okay. So what is the n value for our case? For our
4.
example, n value is 4. So 2 into n minus 1 means, for first line, we will check. Let us check for the first line. Okay. So 2 into 4, 8 minus 1. So 8 minus 1. So that is equal to 7. Okay, 7.
Yes.
But how many is, like total total it is 7.
Yeah,
Okay.
but 2 occupies with that
Yes. So
slash
we
and
will
forward
use this
slash.
3. 2 into
Yes.
n minus 3. Let us use that formula. You have to derive based on the scenario. So
Okay.
8 minus 3. So how many spaces we need to leave? 5.
5.
So is this formula applicable for all the lines or not? We have to check it.
Okay.
Okay. Is it correct? Like for all the line, n means for all the lines, n value will not change. So instead of that, we will take, suppose if I take 2 into n minus, like 2 into n minus 1 will be the total characters. From that, we need to check the current line number. What is the current line number?
First line.
Like we'll see the part instead of testing the type. Like you need to derive one formula. That formula must be
Based on the condition given on the question.
yeah, 2n minus 1 size. Okay. Like total size we are taking total size of each line. So the size of this line is 2n minus 1. Okay. The total size. So the total size of each line, including spaces, everything. Okay.
Yes.
That is nothing but 2n minus 1. So they have used somewhat simple. So total how many lines we will have? N
4.
lines means 0 to n minus 1 we need to. This
Yes.
outer loop is always how many lines we need to repeat. Outer line will use to print any pattern. We use two for loops. First for loop always it will be how many lines that we need to print. Okay. So
Yes.
how many lines that we need to print is, we are starting from 0. It will be up to n minus 1. Actually, we will use less. N lines means we use n, but last line we need to print v. So we need to exclude that last line. That's why I have taken up to n minus 1. Okay. So last line we need to exclude. So in each line, how many values that you need to print, that we will write it in the second loop. Okay. First loop is for how many lines that you need to print. So that we have taken it as I. I is the current line number here. Per hour, I is the current line number. Okay. In each line, how many symbols that you need to print, that will be the J loop. So how many symbols overall that you need to print is nothing but 2 into n
2.
minus 1.
Yes.
Yeah, size value. So in this, what I need to print is, if j equal to I, then you are printing a backward slash. That means, see here, I equal to 0, then j equal to 0 means same column they are starting. If I equal to 1 means the slash should start from in the first column. If I equal to 2 means slash should start in the second column. So what is the current line number? At that line number position, slash should start. Okay, have you got it? So if this, for this line, I value is 0, current line number is 0, so your slash will start at 0.
Yes.
Okay, for this line, I value will be 1. Okay, that means your slash, backward slash should start at position 1. Okay, so for this line, I value will be 2. So that means your backward slash should start at position 2.
2. Yes.
Okay. So
3. N plus 1, N plus 2.
when the j value is equal to I, you need to print a backward slash to your file. Okay. Otherwise, you need to leave that space only, like in which position you are saying, no. So otherwise, you need to leave space. You need to print space to the file. Okay. So when you need to print the forward slash is, when j value is size minus I minus 1. Like this is the formula actually, where the forward slash will come is 2n minus current line number minus 1.
1.
Yeah,
Yes.
2n minus L. L is the current line number we said. Okay, like I, in our case it is I. Okay, 2n minus like this value minus 1 will be the place of your forward slash. Okay, so if your j reaches to this formula, then you print a forward slash. Otherwise, you print a space. So we are specifying herely exactly where you need to print the space, where you need to print the backward slash, where you need to print the forward slash.
Forward slash. Yes.
Yeah. If j value is equal to I, backward slash. If j value is size minus I minus 1, then
forward slash.
forward slash. Otherwise, space.
Space. Yes.
Okay. Even you can write this logic, or even you can follow this logic. If you are able to derive a formula for how many spaces that we need to read initially, like in terms of that also you can derive the formula, and that formula also you can use it.
Okay.
So,
So for that type of question, we had to derive a formula according to the
current line number
condition.
and the total number of lines.
Okay.
In those two values, you should be able to derive the formula.
Okay.
Okay. So after so this by the time you complete both the for loops, you will get the required format, and that format you are writing to the file only, file pointer. You open the file in write mode, and you are writing that format to the file only. Okay.
Yeah.
So at the end of each for loop, j for loop means once the j for loop is over, one particular line is over. One particular line is over. Suppose j value, once the j value is over, that indicates one particular line is over. So you are
Yes.
going to the next line. So before going to the next line, you use a /n. You write /n to the file so
Yes.
that it will move to the next line.
Next
and then
line.
I value gets incremented. When I value incremented, you are going to the second line, third line, fourth line, like that. So I indicate the current line, whereas j will indicate how many values we need to print in the current line. Okay.
And ma'am, at the end, how it encounters the end of the.
No need of end of the file. Here we need to print our required format. How many lines are there? Okay.
Okay.
So at the nth line, so here we did only up to n minus 1 lines. This logic we have used only for the first n minus 1 lines. Whereas
Yes.
for the nth line, we need to print the shape V. The shape. Okay. So
Yeah.
if I value is equal to n minus 1, then you print V. Okay.
Okay.
Else you print a space. This is also repeated size number of times. Size is nothing but 2n minus 1. Okay, it is checking each and every line value. Suppose if it is 0th line, this V will be printed at 0th position. If it is a first line, like we also, for the printing, we need to leave some spaces, no? So
Yes.
exactly at what position you need to print V is when I value is equal to n minus 1, at that place you need to print V. Otherwise, you need to leave the spaces.
Yes, ma'am.
Last line we are printing. For this, what we are doing here is we are printing the last line. So exactly where we need to print V? Only at the n minus 1th position. Initially, we need to leave all the spaces. So I value is varying from 0 to that size. If I value reaches to n minus 1, you print V. Otherwise, you print space. So it will leave n minus 1 spaces initially. At nth, like when it is starting from 0, no? N minus 1 means correct nth place. It is. In the nth place, it will print V. Okay. So
Yes.
last line. This is for printing the last line. this code, and this code is for printing the first n minus 1 lines. Okay, and then close your file. Okay, so
It will go like rows, using the rows and columns.
yeah, like a
Okay.
pattern, given pattern you are writing to a file. That's all.
Okay.
So go to the last one, somewhat typical it is. In a hotel, there is a dosa tawa where dosas are arranged in a linear order. A special flipper can flip exactly k continuous dosas at a time. Tawas dosas are represented by an unsigned integer tawa, okay, where the size of tawa is n is less or equal to 32 bits, and each bit represents dosa's orientation, flipped or unflipped. Write a program to determine minimum number of times you have to use a flipper to ensure that all the dosas in the tawa have been flipped. If it is not possible to flip all the dosas, return -1. Okay, so let me explain the problem first. What is the problem? So there is one dosa tawa. So there you can place at a time some dosas. Let us think that 8 dosas. We can at a time we can prepare 8 dosas with that tawa.
On that tawa, yes.
Yeah. So the maximum dosas that you can prepare is 32. That is given to you. Like size is given to you. How many what is the size of your tawa is given as an input. So let it be n. N is the size of your tawa. Okay. And we have a flipper which can flip n dosas at a time. Say suppose if my flipper size is given to you. So the flipper size is k. Okay. If k value equal to 2 means at a time it can able to flip either these 2 dosas or these 2 dosas. Okay. Or these 2 dosas. At a time it can flip 2 dosas.
2 dosas.
Yeah.
So
K.
four dosas are,
Suppose if k value is 4, at a time it can able to flip 4 dosas.
yes.
Okay. So that is also given as an input. What is the size of your tawa? How many dosas at a time you can have in your tawa is given. And how many flipper, how many dosas it can able to flip is also given to you. That is k. And the current position of your tawa is also given. Like here, this tawa position is represented using ones and zeros. Okay. Suppose I have something like this. If my tawa size is, let us consider it as 8. So the initial position of it, that means this is flipped, this is unflipped, this is flipped, this is unflipped. The initial starting position of tawa is also given. Okay. So this is
yes.
given in an hexadecimal number, unsigned integer. That means it will have only positive values. That value is also given in hexadecimal format. Okay.
Ma'am, how did you understand that it is a hexadecimal or binary?
Yeah, it is given here. Like input, it is an unsigned integer in
A
hex representation of tawa.
Yes.
That means the
Okay.
given value is in hexadecimal format. So that you need to convert into binary.
Okay.
Okay. So that is the representation. So current representation of tawa is given, and how many dosas are there in tawa is given.
8.
At a time, how many dosas you can able to flip using flipper. That
Yeah.
is also
2
given.
dosas.
Okay. So now your task is, so let us consider this example only. Okay. So the current position is 56. 56 means how you can write the 56 in hexadecimal? 5. 5 each digit is represented using 4 bits in hexadecimal format. So 5 how will represent 101?
Yes.
101 is the 5. 4 bits means initial bit is 0. So this is the representation of 56. Okay. So 56 equal to, so 5, and I'm leaving a small space here for our convenience. Okay, 0,
Yes.
1, 1, 0. So this
Yeah.
is the initial tawa position that was given. Okay,
Yeah.
and the n value is given here is 8. That means there are 8 dosas. Okay, and the flipper size is given as 2. At
Yeah.
a time, you can flip only 2 dosas.
Two dosas. Yes.
How it will work? Let me first explain the logic. So first, you can either start from right to left or left to right. Okay, you can do
Okay.
it either from this side to this side or this side. So I'm starting from here. Okay, so
Yes.
here, so my flipper position is here. Suppose
Yeah.
my flipper is at this position. So that means if it flip, generally when it will flip is, if the current position is 0, then it will flip. If current position is already 1, it won't flip because it is already flipped.
Okay.
Okay.
So 1 is the flipped and 0 is unflipped.
Yeah, unflipped. So if it
Okay.
is unflipped only, it will flip. Okay. So now my flipper is here. So if I flip, what will be my string now? This value, my current tawa position will be. So if it
0,
is
1.
at this position, if it flips, it will flip 2 because the size of tawa is 2. That means these 2 will be flipped. These
Flipped.
2 will be
Yeah.
flipped. So the current position will be 0, 1, 0, 1, 0,
0,
1,
1,
0, 1.
0, 1. Yes.
Okay, these 2 will be flipped. 0 will become 1, 1 will become 0.
Okay.
Okay, so this is after first flip. This is the status after first flip.
Yes.
Okay.
Ma'am, flipper can flip the two dosas, but first one is not flipped, but the second one is flipped.
No. It will check its current position. It will check its
Okay.
current position. At the current position, if it is 0, then only it will flip. Otherwise, no.
Okay. Yeah. And if flips the two,
Yeah, if it flip means it will flip its size.
okay.
So because the size of the flipper is 2, so it will, from this position, the 2 dosas will be flipped. Suppose if its
Yes.
position is 4, its size is 4, from this position it will flip all the 4.
4. Yes. Okay.
That is the scenario. Now we will move. So at this position we have tried already. Now we will check your flipper. You move your flipper to the now this position, second position. You are
Yes.
moving from right hand side to the left hand side. One position we will move the flipper. Okay.
Yeah.
So now my flipper is here and my current value of the flipper is unflipped, so it will flip. So then what will be the value now? Now tell
0,
me.
1, 0, 1.
0, 1, 0, 1, 0, 0, 1, 1.
0, 1.
So my flipper is here. So these two values will be flipped. Okay.
Yes.
So 1 will become 0, 0 will become 1.
Yes, ma'am.
Okay. So this is after flip. After
Flip.
flip 2. Second time. After flipping the second time. The scenario of your tawa after flipping second time.
Yeah.
Now your flipper position is now this.
Yeah.
Okay.
Here are
So,
two unflipped dosas.
yeah. So from here again I have a 0. So it will flip. If
Yes.
I have a 0, it will flip. If I have 1, it won't flip. Okay.
Yes.
So now it will
Both
flip
zeros
these two
become 1.
values. 1.
Yes.
So what will be this value now?
0,
Tawa
1,
position.
0, 1.
Wait. 0, 1, 0, 1.
Double 1, double 1.
Double 1, double 1. So
Yes.
this is the position of tawa after
Flip 3.
flip 3. Now again now your
Now it
flipper will
encounters
move
1.
to this 1. It won't flip. Again it will come here. This is also 1. It won't flip.
Yes.
So when it comes to this position, again 0. So it will flip. So now
Okay.
it is here. If it flip, these two values will be flipped. These two values will be flipped.
Flip. Yes.
So the current tawa position will be now 0. Okay, 0, 1,
0, 1,
1,
1, and all the 1.
1, 1, 1, 1. So this
Yes.
is the position of tawa after
After the flip 4.
flip 4. Okay, so now my flipper position is this.
Yes.
It will flip both the values. So the tawa position will be 1, 1, 1, 1, 1, 1, 1, 1, 1.
Yes.
Now this is after flip
Flip
5.
5.
So you are asked after how many flips all the dosas will be in a flipped position. Now all the dosas are in flipped position.
Yes.
Okay. So how many flips that are required? Total?
5 flips.
So total 5 flips.
For
Total
8
5.
dosas.
Yeah, for not for 8 dosas, like for the given current position of your tawa. This is
Yes.
the suppose if your current position changes, we can't say exactly it is 5.
Yes.
It can
Yes.
be
Yes.
something else. So
Yes.
for the given current position of your tawa, we require 5 flips to flip all the dosas of your tawa.
Yes.
Okay, so that is what you are asked to do. Your output should be an integer representing the minimum number of flips required to ensure all doses are flipped.
Flip. Yes.
Okay, so you are given current representation of tawa in hexadecimal format, and n is the total size of your tawa, and k is the flipper size.
Yeah.
How many dosas it can able to flip
flip
at a
at once.
particular
Yes.
instant. So that is given. Suppose if it is not possible to flip all the dosas, even after your flipper position is changed from right to the left. Okay, your flipper already reached to the left side. You have started at
Yes.
right position. Your flipper reached to the left position. Still, you didn't get all ones. Then in that case, you need to return -1.
Okay.
It
We
is
had
not
to start
possible.
from left to right.
Yeah, you can
Again.
start either from left to right. If you start from right, also you will get the same scenario.
Okay.
You will get the same value. Either you can
And we
start
had
from
to
left to
do
right or right to left.
until encounters all 1.
Yeah, not until all. Yeah, until your flipper reaches from your starting position to the other end. From
Okay.
one end, you are starting your flipper. Till your flipper reaches to the other end, you have to check whether after reaching to the other end, you have to check whether all are ones or not. If all are ones, you return a counter value. Otherwise, you return -1. So
Okay.
you need to, how many times you need to do is, your flipper should start at 1 and it should reach to the n-1, like
End of the
your
yes.
end of. So once it reaches to the other end, you check the status of your tawa. If all are ones, you return the counter.
Okay.
Otherwise, you need not return the counter. So counter, when
Counters
we
mean
increase
how
it,
many flips we
yeah,
required
yeah.
are
Whenever there is
according
0
to the
in the
condition. If
whenever
there is
there is 0 in the current flipper position, there we are flipping. So you increase your counter.
okay.
Okay. So that is the, have you understand the problem? Then we'll see the
Yes, ma'am.
implementation. Okay. So in the main, we are reading the tawa position as a percentage x means hexadecimal. Okay, and
Yes.
n is the size of your tawa, k is the number of size of your flipper.
Yes.
Now, so you are calling this function with these values as inputs, and this is returning one counter value. That counter you are displaying.
Yes.
Okay, this is your main. Okay, now see the function. Initially, your flipper starting position, we are calling it as 1.
Yes.
Like we are starting position of flipper is 1. So always we are in this code we have written from LSB to MSB, that your flipper is starting at the least significant bit, you are moving towards most significant bit.
More significant bit, yes.
Yeah, you are starting from right side and you are moving to the left side.
Left side.
Okay, so start is 1, and here what we are doing is flipper mask. This flipper mask is used to check whether the current in the current position we have 0 or 1.
1, yes.
So to check that we require this. So the initial flipper mask is if your flipper size is k minus 1 times you left shift. That means wait. I did all the iterations and then stored it in a file. Okay, wait. So initially, your what we are doing, your flipper start flipper mask. So this is your flipper mask initially. So your k value is 2. So it will be k times it will perform left shift on 1. So that means
Yes.
at kth position you will have 1. The remaining will be zeros. Okay. So because 2 in the second position you will have 1. The remaining will be 0. Okay. So each time this flipper mask will be left shifted once. Okay. So the next flipper mask is this 2 zeros 1. Next flipper mask
Yes.
is 3 0. So each time we are left shifting the flipper mask. The
By
initial flipper mask value is k minus 1 times you need to left shift the 1. Okay.
okay.
Like that we are till we reach to the flipper mask to the n minus 1. We will stop. When flipper mask reach to the n minus 1th position, n minus 1 times you need to do this. So because n value is 8, we need to do this for 7 times.
Yes.
Okay. So once we reach to the end, we stop your flipper mask value. So now what we need to do here is, okay, so flipper start, flipper mask, you understand both. Now counter, initially my counter is 0. Counter is 0. How many times I need to do this is n minus k plus 1 times. Suppose think that my tawa size is 8, my flipper size is 4. How many
Yes.
times I need to do? Only 5 times, because when I do the 5th time, all the remaining dosas will be flipped.
Yes.
Okay, so n minus k plus 1 times I need to do. Okay, so for our scenario, n value is 8, k value is 2,
It's
n
2.
8 minus 2 is 6 plus 1, 7 times we need to do. Okay,
Yes.
so this is to be repeated 7, like n minus k plus 1 times. Okay, so what I am doing is whether I am checking whether in the current position I have 0 or 1. Okay, so to check that at the current my flipper current position, at the my flipper current position, whether I have 0 or 1, to check that what we are flipper start and operation, logical and, this is a bitwise and with the tawa. So if this value is 0, that means in the current position I have 0. So if condition to be true, it should be 1. So that's why I'm taking a negation. Okay.
Okay.
Like I'll show the example. Don't worry. So this value, if I perform the AND operation of the flipper starting position of the flipper with the tawa, if I get 0, if I have a
Then
0, this AND operation will result 0. Total this AND operation
yes.
will result 0. Negation
Yes.
of that means 1, true. That means I need to flip. If this condition is true, I need to flip. Okay. So flip
Okay.
means how I will flip is perform the XOR operation with the tawa and flipper mask. If you perform the tawa and flipper mask XOR operation, your tawa will be flipped. At the current position of your flipper, your tawa, like we have written the steps, no? This will be performed. Yes. This will be performed. In each step, that flipping is performed. For flipping, to perform that flipper, what we are doing? We are performing XOR operation of your tawa with the flipper mask. Okay?
Yes.
So,
yes.
Now we have flipped. If this condition is true, we are flipped. When we flipped, you increase the counter by 1. Okay? So here we are flipping. So because we have flipped, so increase your counter by 1. So you don't, when you don't want to flip, if it is not 0. So how will you know that? If you here you get a non-zero value, the negation of that will be the negation of that will be non-zero. So in that case, it won't perform flipping. Okay.
Yes, it remains same, and we will step 1 plus.
Yeah. So in each time you left shift your flipper starter and left shift your mask. I said no.
Yes.
Each time you move your flipper position. To move your flipper position, just we need to perform left shift. Flipper position as well as mask also.
We will move from least significant bit to most significant bit.
Yeah, we are moving
by 1.
In here we implement like that. Okay. So
if it
like
encounters
that,
1, then
like that you need to do it n minus k plus 1 times the same task. Okay. So that I did it here with the given example. You see, check it. So initially, this is my 56 value. Okay.
Yes.
So initial start value is 1. Flipper start is 1. 1 is represented in the hexadecimal like this. I am performing the AND operation with this. So I am getting 0. So that means negation of this will be true. So I need to flip here. Based on this value, I can decide whether to flip or not. So if I get 0, negation of this I am taking. So it will be true. True means I need to flip. So flipping means what you are doing? You are performing XOR operation of your tawa and flipper mask. So this is the current position of your tawa 56, and flipper mask is initially left shift k minus 1 times. So this is your flipper mask initially. So if you perform XOR operation means when you have a different values, you will get 1. Same values, you will get 0.
0.
Okay. So here 0, 0, 0, 1, 1, 0, 0, 1, 1. So like you will get a different value. When you have a different values, you will get
then get
0, 1, 1. Same values, you will get 0.
Yes.
Okay. So this is your tawa position. Now after first flip, this is your tawa position. 54 is your tawa position after first flip. Okay. So now you take that current flip, and then you left shift your starter. So if you left shift your starter, it will be like this. If you left shift your flipper mask, it will be like this. One position left we have moved from previous flipper to here. Okay.
Yes.
So now you perform AND operation. AND operation means when both are ones only, it will be 1. Otherwise, it will be 0.
0.
Okay? So again you got 0. So again you flip it. Here also you got 0. Again you flip it. Increase the counter. Here you got non-zero value. So negation will not, so you are not flipping here. Just only you are changing a flipper mask. You are not flipping. You are not flipping.
Yes, because it encounters 1 here.
Yeah. So non-zero. Here also non-zero value, no flipping. So when there is no flipping, you won't increase your counter. Okay. So again you got 0 here. So when it is 0, you need to flip and increase the counter. Again here also you got 0, increase the counter, flip and increase the counter. Now once we reach to n minus like n minus k minus 1 position we have reached. Like we reach it to the most significant bit position near it.
Yes.
Now, now what we need to do is, with the current position of tawa, whether all once we got all are flipped or not, we need to check. So for that, what we need to do is, tawa is to be perform AND operation with tawa flipped value. Tawa flipped value will be 1, like it reach it to the most significant position. So
Yeah.
in the MSB it will be 1, remaining will be 0. So with this you perform AND operation. If you perform AND, because all other are 0, so you should get the, if you get the same value as tawa flipped, that means all are ones. Otherwise,
Yes.
0. Okay, if you
Yes.
get the same tawa flipped value, tawa and tawa flipped value is equal to tawa flipped, that means all are ones, you can assume, and then you print your counter value. So otherwise,
So
you return -1.
we perform the AND operation with the
Yeah,
initial value with the flipped value after
not
the
initial
entering.
value. End of your tawa position with the end of your flipped mask value.
Yes.
Okay, with that you perform the AND operation. If that is equal to flipped mask, wait, here we have checked. If tawa and tawa flipped is equal to tawa flipped, then return the counter. Otherwise, return -1. It is not possible to flip all the dosas at it.
Yes.
Okay, like
Because
with some iterations.
flipper has a size of 2.
Yeah. So that is the logic.
Yes.
Okay. So I think you understand the problem.
Ma'am, you
Yeah.
understand, you explain very well. That's why his question feels very simple. But when I saw the question like that, then it feels very difficult. So
Like
I,
you practice so many examples, then definitely
okay,
whenever we are framing, we will include any of these logics only. Maybe the question formation might be changed, but the logic inside that will be like this. So if you are
okay,
able to practice all the questions, then you will you can able to
able to
guess
form a
the
logic for
logic.
that too.
Yeah,
Yeah.
you can form the logic for the required situation.
Okay.
Okay. So any other doubts?
No, ma'am.
Okay.
Thank you, ma'am.
So I'm closing the session now.
Yeah. Okay. Okay, ma'am. Thank you.
Okay. Good night.